a new chapter. So we'll be done with wave properties. I would like to start Doppler effect. Doppler effect takes one class, okay? So এটা করে ফেলতে যাচ্ছি. Right. So in math we can move on faster. So last class last class we did this quick recap. We did intensity. Okay, and intensity is the amount of energy dissipated per unit area. It depends on two factors: how far you are from your light source and how big is your light source, or how big is the area on which the light falls. So এখানে একটা power source আছে. What you need to find is, this is 100 watts, right? You need to find out how much power does this small area here receive. So that's the question, okay? Because obviously it's not going to be 100. So how much power does that small area receive? 25 point. I think you said this last class as well. It's I think it's the right number. The power might be a problem. You consider that the base is centimeters. There are two equations for intensity. One is intensity equals to power divided by 4 pi d square. The other one is intensity equals to power by area. Both of them will be needed here. So you can't just use 4 pi d square. Uh, 25.5. No, I think it's close, but you need the correct units. I think there's a problem with the unit. Answer. How much? Right. আচ্ছা এটা করে দিই কেমনে করতে হয় স্ক্রিনে দেখো একটু the process. So there are two steps here. Step number 1 হচ্ছে intensity at 5-meter distance. So intensity at 5-meter distance হচ্ছে basically you need to find out by the time the light travels from here to all the way down there, what is the intensity? Can you tell me which formula should I use for this? The variation of intensity with distance. What formula is that? Yeah, very good. So intensity equals to power divided by 4 pi d square. So this one is the equation that's based on how far you are, how intensity changes with distance. Okay. Intensity we do not know. Power is 100 watts, and this is going to be 4 pi d square, where your distance is 5 square. That's the intensity. So can you tell me what is the intensity at the 5-meter distance? 0.318 unit watt per meter square. I'll tell you why the unit is important here. It's kind of helpful. Okay. So এখানে যদি হচ্ছে 0.318 watt per meter square আসে, what does it indicate? That at this distance, the power is 0.318, right? For what size? Or what area? 1 meter square, 0.318 watt per meter square. So আমরা যদি হচ্ছে এই লাইট থেকে এই বোর্ডে আসেন, this board is 1 meter square, right? How much power does this board receive? 0.318, right? But the problem is, look at the area there. Is it the size of the board or smaller? Yeah, it's a smaller area, right? Will it get all of the 0.318? No, right? So 0.318 is for 1 meter square. How much should it be for that area? You can use what method if you want? Unitary method. So unitary method is completely fine here, but I'll show you how to do it the other way. So this is the intensity. So intensity, I don't know, power by power over the area. So power over the area would be intensity equals to power divided by area. What is the intensity? 0.318. What is the power? That's what we're trying to find out. What is the area of that place there? 8 divided by 100 into 10 divided by 100, right? So এটা করলে যেটা আসে, that's my answer, is that 2.546 into 10 to the minus 3. Right? Which power? Here. No, this is what we're finding. We're finding the power falling onto that area there. How much power does that area receive? Is everyone done? Okay, so we'll do the next part. এখানে ছোট একটা জিনিস অ্যাড করে রাখি. I know you'll be able to figure it out, but হচ্ছে তাও for reference there. This is the graph for intensity versus distance. Right. Can you tell me what should this graph look like? Intensity versus distance. How would this graph look like? Yeah, exponential and positive or negative? Negative, right? So do you like what's the name of this law I told you the other day? Inverse square law. So inverse square law graph থেকে এরকম দেখতে হবে. right? What's different? That's fine. Have you guys done this in math where there's this function called e to the power x? Have you done the graph for e to the power x? Okay, do you know how e to the power x and e to the power twice x compare? Yeah, online is horrible to know. I don't know why. So it extra knowledge or was it there in your syllabus? That's very disappointing. I mean, so confidently know also. So what do you mean? Anyways, we don't have that. Don't worry. ওইখানে যেটা ছিল e to the power x এর গ্রাফটা একভাবে e to the power 2x, right, is steeper. 3x is even steeper. 4x is even steeper, right? So the idea is that when you have exponential graphs out there and you change the power, right? The one we have is I equals to p divided by 4 pi d square, d cube, d to the power 4. They're going to show inverse, right? But what changes about them? It's the right term হচ্ছে the eccentricity of the graph. মানে গ্রাফ হচ্ছে very smooth হচ্ছে e to the power y equals to 1 by x. 1 by x squared কি হবে? স্মুথটা একটু like it'll be a little sharper, একটু এদিকে যাবে। তারপর 3 করলে আর একটু এদিকে যাবে, 4 টা করলে আর একটু এদিকে যাবে। Basically it starts to turn very abruptly the more the power is, okay? Part of math, physics এ লাগবে না। So আমি দেখাই কি করতে হয়। And probably there's a issue with physicists getting this wrong. কারণ এটা accepted না। এই যে এটা গ্রাফটা for inverse square law, right? They don't accept this. So my question for you is can you come up with an acceptable graph? কি করা যায় এইটাকে প্লট করতে গিয়ে? It is a graph. It is inverse square law. But how can you make it more acceptable? There's something wrong here. I'll tell you what's wrong here. আমি যদি এরকম একটা random curve draw করতাম এই যে like this, এটাও কিন্তু দেখতে similar হইতো। So lab when you're doing this or that, you might be confused. Maybe I got it right, but you actually got e to the power 1 by d cube. They look very similar. That's my point, right? So what's the way out? How do I make it better? No, I can't just make it steeper. I mean, what do I do to make it steeper? Base more pointed. Do you guys understand my question? My question is, this graph is inverse square law. There's nothing wrong here. But with the problem the inverse square law let's say inverse cube law. So what would that be? Y equals to 1 by x cube, right? How would the graph look like? একদম similar. You wouldn't even know any difference. But একটা কিন্তু হচ্ছে 1 by x square and the other one is 1 by x cube. Can you just look at them and tell which one is what? I mean, can you tell which one is the inverse square and inverse cube here? Neither of them could be right. We just random sketch course, right? So it's very difficult for us to figure out. But there's a way to improve this. It's on their journal, paper 2 journal, and also for MCQs. A lot of MCQs show up on this, right? So what should we do here? What's the way out? What's the way that's more readable and more easily workable? You can work with that graph easily. Bigger access, like zoom in more. I think my question wasn't clear enough. I'm bully keyboard. I mean, graph China. You guys are trying to work with this graph. Okay, I don't want this graph. This graph is not what I'm looking for. So what can I do here? So we can make d squared by Just a second. Bully keyboard. You're close. So what you need to do here is plot the graph again. But this time you need to plot the graph for a new unit. Unitটা হচ্ছে এটা না, unitটা হচ্ছে 1 by কি হবে d square, which is 1 by meter square. And what would that do? What would that do to my graph? Yes, it'll turn into a straight line. And isn't that much more convenient to observe, right? Curve মধ্যে কিন্তু খুব difficult. এখন এখানে যদি আমি এটা draw করি x to the power 3, ওইটা কি হয়ে যাবে? একটা curve হয়ে যাবে. Okay, so the idea is you had this, don't pretend, okay, because you had the law of PV equals to KT. I mean, O levels say P1 V1, P2 V2, gas laws it. So you can gas laws are do the graph plot for P versus V, right? It's the inverse square or inverse graph, right? But what did we use to plot instead? P versus 1 by V, and what would that give us? A straight line. And what's more easier to work with, a curve or a straight line? Straight line. A gradient বের করা যাবে, y intercept বের করা যাবে, area under the graph is a triangle, right? So আমাদের aim হচ্ছে we do this. And is this only for this particular question? No. Okay, you have plenty of questions where they'll do this. So try to understand this idea that whenever you manipulate your axis, right, you can always convert that into a what graph? Straight line. Have you done this before? Like how to convert any graph into a straight line? Okay, so yeah. That wasn't a convincing yes, but the x squared equals to 5 root cube root x. Quick, okay? I'll give you 30 seconds. Tell me, what does this graph look like? এই গ্রাফটা দেখতে কিরকম তাতে বলো You have AS math knowledge. I expect something. What would this graph look like? Y square equals to 5 cube root x. What could this graph look like? Ten seconds left. Something like that. Anyone else? Okay, so the answer is I don't know. I have no clue. I just scribble some numbers here, right? But I'll tell you what we can do here. Let me show you. So what you need to do here is work around it. So I'll make my y-axis y square, okay? And I'll make my x-axis cube root of x. What should the graph be? Yeah, straight line pass into the origin, and at a gradient ki hobe 5. Because you know what I did here? I converted my y-axis entirely to y square. I have converted my x cube entirely to the x-axis. That's like y equals to mx, right? And the gradient is 5. So the idea is in physics, you will see the most absurd graphs. A2 te gye to it's worse than this, okay? But what's the skill that you need to have to make your life easier? Convert them into what line? Straight line. There's another one, and I know you're gonna say no, but I know that you know. Ota hocche how to convert like an exponential function into a straight line. Yes. Okay. Logarithm used for natural. Right. So, I mean, Doppler effect aage jekhon jagay korle hobe. Okay. So Doppler effect, if you have space missing somewhere, so Doppler effect aage just look for any space. Right. So before I move on, I hope you have the graphs copied. Okay. So these are the two graphs out there. One is the inverse squared law graph. Inverse square law? No. D squared to graph because it's changing. D squared so its square factor and it becomes a straight line. Done. Very good, Bolo. We'll just do this last part here and then start Doppler effect. Ready? Okay, so what's left here? What's left here is the relationship between intensity and amplitude. So it is just one single equation, and students struggle with this a lot, again, because of the lack of ability in math. Okay, so question they power. So this is variation. This is the heading, okay? Variation of intensity and amplitude. So educational, just a couple of minutes. So when you have a light source, right, at the light wave, electromagnetic wave has many properties that basically represents the energy it contains, right? So what are the properties of a wave? Give me 5 properties of a wave. Amplitude, frequency, wavelength, speed, one more. Time period, frequency, interchangeable. So V equals to F lambda মধ্যে তিনটা, right? R থেকে বুঝলে তোমরা amplitude, right? So what's the last one? Trough and crest. Oh no, that's not a property. That's just a place, a name for a place, right? So arekta property হচ্ছে your intensity. You know how strong the wave is. Isn't that a property as well? So the question is, intensity is actually a dependent variable of the previous quantities we saw. So একটা লাইটের কোন property একটা ওয়েভের কোন property basically is the representation of intensity, মানে কোন জিনিসটা intensity কে vary করে. We get the point. Intensity মানে light কমে যাচ্ছে, power কমে যাচ্ছে, but wave এর কি কমে যাচ্ছে? But if you think of a wave coming to you from a very far distance, right? তো কিছু চেঞ্জ হওয়ার কথা না, but power কমে যাচ্ছে না, so something must have happened, right? So what decreases is amplitude. So amplitude is a representation of the energy of a wave, and we have done this before. Kemne, if you remember, I think তোমাদের সাথে extra করে করছিলাম in a ripple tank. You remember ripple tank? So if you hit the water surface with more energy, wouldn't that produce more amplitude? And do you remember in sound there was something called loudness, right? When you have a lot of energy in your sound, does the sound become high pitched or does the sound become louder? Louder money, more energy, it can travel further, right? So amplitude is a very good representation of what? Energy. But there's a controversial point here though. Frequency is also related to energy. And the reason behind that is a little complicated. It's because we eventually learn, heads up there, we eventually learn waves are actually particles and particles are actually waves. So there's a question in your A2 where you learn what's your wavelength. And you find your wavelength. Okay, so we all have wavelengths and we are waves right now, but we do not exhibit wave behavior. What do we exhibit? Particle behavior. And particles, right, have what? Mass. and waves. They have mass, they have frequency and whatnot. What do they turn themselves into? Particles. When it's called wave particle duality. Why am I saying this? Because you'll find in most places they'll say frequency is what the energy is. It's correct, but it's just a particle. And আমরা যেটা নিয়ে discuss করতেছি our chapter is exclusively what? Waves. Waves এর মধ্যে which is the feature? Amplitude. Okay, so once we finish our whole syllabus, everything will fall into its place. Right now, just understand that amplitude is the energy representation of a wave. Okay, and as the amplitude increases, what increases? Energy, right? And intensity as well. Intensity is basically energy per unit squared, right? So there's actually a link between amplitude and intensity. Okay, so intensity of a light is proportional to amplitude squared, and that's it. That's the topic. Okay, then I'll give you questions and you'll understand why students have trouble here. But that's it. Definitions. If they ask you what's the relationship, you basically just say this in words, okay? Which is intensity is proportional to amplitude squared. Oh, sorry. Oh yeah, the way the energy changes is based on how the distance varies. So distance has a square relationship on how far you are. How is intensity related to energy? Intensity is actually energy. What is intensity? Power by area, right? So intensity is the power that one area receives. What is power? Energy that's provided every. Okay. Why? It's a question that some students ask. Why don't we just use energy? Why don't we use power? So I have a simple answer for this. Okay. This table, right, receives 5,000 joules from a light. Okay. Another table receives 10,000 joules from another light. Okay. Can you tell me which light is brighter? 5,000 joules from a light source. Our table 10,000 joules from another light source. Can you tell me which one is brighter? Sorry. Yeah. So exactly. We don't know the distance. Just energy compared. Let's light is on, right? For 5 seconds, and it gives 5,000 joules. And that light was for a day, and gave 5,000 joules. Wouldn't it be appropriate to compare light sources? Because one was on for how long? 5 seconds. The other was on for how long? A whole day, right? Is it a appropriate comparison to compare the brightness? Why? Because the energy over time very different. But if I find the energy it gives every second, then a much more appropriate comparison because I have a standard for the time out there. That's what's energy per second? Hour. Yes. Hour. Okay. So intensity is proportional to amplitude square. I mean, at example, they don't. Come on, a question. Past paper, so you have this graph here where this is intensity watt per meter square, and this is distance meter, and it's a wave. So this is how the intensity is. Right, so this is a reference graph. What is the amplitude variation for the wave? 4 to -4. The way your amplitude varies is the way your what varies, intensity. So how much intensity by take the average of that graph. Isn't the wave fluctuating? Energy, so isn't intensity fluctuating? Let's say this value is 20 here, and this is -20 watt per meter square, right? Can you tell me draw or sketch the graph for intensity versus T if amplitude is increased to 5 centimeter. Try girl. Let's see your math skills. So yeah, intensity, sketch the graph for intensity versus T if amplitude is increased to 5 centimeters. একটা heads up there, okay, this question is entirely based on something called the unitary method. Okay, so if you know unitary method, you should be fine with this. Yep. Oh, sorry, at 5 meter. Right, so যার কোয়েশ্চনটা বুঝুন আমি বলি, my amplitude was 4, my intensity was 20. My amplitude is 5. What is intensity? That's it. That's the question, okay? 31.25. Yeah, highest point is that's 31.25. Bagira. Yeah, graph will look same. They'll like have different amplitude. 31.25. Okay, Koreata, 1.25 আসে. Let's see. Show I screen it, because I'll be leaving this chapter soon. What's the thing here? So the thing here is that we know that intensity is proportional to what? Amplitude squared, right? So if my intensity is 20, sorry, my intensity is 20, what is the corresponding amplitude? 4. So if my intensity is, my amplitude is 5, what is x? That's the question, right? কিন্তু এখানে problem হচ্ছে, is it directly proportional or with a square factor? So এটাকে কি করতে হবে side গুলো? Squared. So you squared this side and you squared that side as well, and এখান থেকে x এর value যেটা আসে is your answer. So 25 into 200 by 8. How much is it? 31.25 watt per meter squared. So that's like your typical question. Now, a ছোট additional step দিব, এইটার উপরে base করে, okay? What is the amplitude when intensity is 40 watt per meter square. So yeah, try this. What is the amplitude when the intensity is 40 watt per meter square? So আমার এখন amplitude দেওয়া, you find out the intensity. উল্টা মানে? Oh, so what is the amplitude? Yeah. Amplitude-টা হচ্ছে বের করতে হবে, intensity না। Five point six six. 4√2. Yeah, I mean it's the same thing. It's just reversing the whole math, right? 4√2. Yeah, it's going to be intensity proportional to amplitude square once again. Right, so intensity কত ছিল originally? We use that as a reference. Actually, 20 is due to 4 squared. So 40 would be due to x squared. Mucho কেন x squared? And then x is equal to 40 into 4 squared divided by 20 root over. How much is it? 5.6 something. That's it. Okay, so any questions? It's just intensity proportional to amplitude square. Where do you get this question? It is standalone ওরকম আসে না, MCQ তে আসে অনেক, but structure কোথায় আসে? Remember the math we just did today with the lamp, and wasn't there intensity change? তখন ওরা জিজ্ঞেস করে ওইটা যদি originally এই amplitude হয় লাস্টে কত amplitude হবে, so they make it part of another question all the time. এটা on its own খুবই rarely আসে. It's just a formula, কিছু নাই এখানে. Okay, no explanation or anything. All right, so we are done with wave properties. Are কিছু বাকি নাই, I believe. Yeah, that's it, right? So সবগুলো done. So আজকে নতুন একটা topic start করব. এটা তোমাদের like syllabus এর মধ্যে is a standalone topic. It's called a Doppler effect. So yeah, 7.3. Next page যাও. Page 35. Okay, I'll be showing you something right now. Eta is basically what Doppler effect is. Okay, so আমাদেরকে বুঝতে হবে what is going on here. So let me show you what it is. I'll show you a couple of demonstrations. Right, so first one is this one here. Right, so listen to the sound, okay? I think the sound is on. এটা শুনতে হবে, নাহলে বুঝানো difficult. You notice what happened to the sound, right? So the thing is, sound changed, obviously. Can you tell me what of the sound changed from whatever knowledge you have? Frequency. Frequency can change away. But did the sound, frequency is a pitch of a sound. And there was another property of a sound known as what? Loudness, pitch and loudness, right? So as it went by, our Shunok, what was it that changed? Yeah, loudness, right? When it was very little quiet, then it got very loud, and it became again quiet, right? But the thing is, যে জিনিসটার উপরে ফোকাস করতে হবে এখন আমাদের গাড়ি হর্ন যেটা থাকে, right? Is it a variable sound? No, right? Isn't the constant sound all the time, right? But এখানে যদি সাউন্ডটা শুনো, so sound has two parts কিন্তু একটা হচ্ছে loudness আর একটা কি pitch, right? Did I make you hear sounds a few classes back? ওই যে tone, ওই টোনটা দিয়ে বুঝাবো আবার, ওকে? সো ওই যে এখানে যে প্রবলেমটা হচ্ছে the sound is changing as well, okay, which is not supposed to happen. So আমরা যেটা করবো এখন, I'll show you from the point of view of the driver horn দিয়ে যাচ্ছে, driver কি শুনতেছে, okay? So see what happens there. So this is from the point of view of the driver. মানে এটা কেন শোনালাম, you probably have seen this happen, মানে এরকম সাউন্ড চেঞ্জ হচ্ছে, like ambulance এর জন্য অনেক prominent জিনিসটা, right? So this one is a better example. Then the sound change, right? Now let's see from the point of view of the driver কি শুনতেছে? You notice this, the driver never heard any sound change. So my question for you, okay, very important question, the sound change is from whose point of view? Observer. Okay, so a effector where the sound itself changes, right? And it changes for the person listening, not the person producing it. It's called the Doppler effect. So Doppler effect essentially means that as you move in, right, the sound changes from somebody who's hearing it. It's called the observer, and the source, right, is not changing. It discovered the person who Doppler came up with this, many years back in the 1800s. We didn't have these kind of devices out there. So he did this experiment. Could be elaborate. He took a orchestra, right, and he put them on a train, on the roof of a train, and they asked the orchestra to play like a common tone out there. Our conductor থাকে না, যারা হচ্ছে conduct করে the orchestra, তাকে হচ্ছে প্ল্যাটফর্মে রাখছিল. And as the orchestra was playing his conduction, মানে যে conductorটার হচ্ছে composition, as the train was going by, he heard his band play the sound, right? But the sound became what as the train went by, different. But the band কিন্তু continued to play the same sound. So because তখন the microphone এত কিছু ছিল না, it's your ears that can detect it, right? So the conductor obviously knows the notes of a musical instrument very well, right? So when the train went by, he found that the notes were changing, but the notes never changed. The people who were playing the music, right? What notes were they playing? The same note, right? So it was an effect for whom? The person who listens, right? And this is called the Doppler effect. And Doppler effect কেন হয় is not really part of our syllabus, but I'll show you why it happens. The thing that you need to know is what's the consequence of the Doppler effect. And I believe we have done Doppler effect to some degree. Do you remember when? Astrophysics, right? When stars move away from you, they start to appear what? Redder, right? But are they red? No, they're just like our sun, right? So why do they appear red? Because they're undergoing Doppler effect. They're moving which way? Away from us. Okay, so এইটাই হচ্ছে the topic. Hopefully we can wrap it up next class because it's just a formula.